Hi, I'm George Winslow. This is my K12 sample lesson for geometry. As you can see here, I've just laid out my learning targets, formative assessment criteria for success. Feel free to pause this and review it. Just to let you know, G5, this is the Virginia State SOL standard for this topic in geometry, which is given three side lengths, determine whether they can form a triangle. Hello, welcome to Geometry with Mr. Winslow. That's me, my Bitmoji there. Glad to see you. This is a recorded lesson about the triangle inequality, so feel free to pause it. I encourage you to do so, to pause it and work ahead whenever prompted before I give my demonstration. Try it yourself. So this is a warm-up. Review a little bit of vocabulary. Is every equilateral triangle an isosceles triangle? You have our choices, yes, no, or I'm not sure. Go ahead and pause and think about it. Now that you've done that, is every equilateral triangle an isosceles triangle? Well, equilateral means that all three sides are the same length. Isosceles means that you have two sides that are the same length. So technically, if it has all three sides the same length, then there's a pair of sides that are the same length as well. It is isosceles. The answer is A, yes. What do you think? Could a contractor use pieces of wood of these lengths to form decorative triangle trim on a roof as in the image below? The lengths are 3 feet, 4 feet, and 5 feet. I don't get too bogged down in the details and thinking that are we making this triangle or this triangle out of the 3 feet, 4 feet, 5 feet lengths. I'm just wondering, can you put those three lengths together to make a triangle? Go ahead and think about it. So to show you the answer to the question, I have prepared a Desmos manipulative that I made just for this lesson today. Here it is. So just to remind you, by convention, we have these points, capital A, capital B, C1, and C2. So capital letters represent points. And we also talk about angles by naming the point that's at its vertex. I have sliders that I made here for side A. So you can drag this and make side A bigger or smaller, make side B bigger or smaller, make side C bigger or smaller. Not necessarily a rule, but I will prefer usually, when possible, to make A, B, and C be the side lengths in increasing order. So whatever's the largest side length will be C. Angle A is the one that's across from side A. Angle B is the one that's across from side B. So since these are the ones that are adjustable, point C is variable. The idea is we want to try to make it so that C1 and C2 fall on the same point. I also have these circles here. Notice that the circle moves with the length of side A, and whatever the angle is, the measure for angle A and angle B, the endpoints of these side lengths have to fall on the circle, because the circle is the set of all the points that are at that distance away from the point. So the idea is we want to try to put in the side lengths that we're given and adjust the angles so that both C1 and C2 end up on the same point, which is going to necessarily be the intersection points of the circle. Hopefully that makes sense. So the example question was 3, 4, 5. Notice, by the way, that you can do the sliders, but you can also just directly type it in if that works better for you. So I definitely want these points to try to land right there. I have to make angle A a little smaller, end up about there. That looks pretty good. And this one needs to be a little smaller too. So it looks to be around there. If we zoom in, looks like we might be a little bit off. And let's see, I'm gonna just fine tune this a little bit. 36.87 and 53.13 is about where we want these to fall. So that looks like a pretty good triangle. I'm not incredibly concerned about the exact angle measures, of course, but we just want to try to make it so that we can see the triangle. So we want to be as accurate This is appropriate. So 3, 4, 5, yes, that does make a triangle. That's what it looks like right there. Okay, now it's your turn to try. I encourage you to pause between each of these, try it yourself. This is the link to that manipulative that I made for you. So click on that, open it up, and you can adjust the side lengths A, B, and C to be sides given, and then adjust the angles to try to see if you can make a triangle. Okay, here we go. First one is 7, 7, 7, which is a special kind of triangle mentioned already in this lesson. It is an equilateral triangle. All three sides are the same length. And as we may know from prior knowledge, if it's an isosceles triangle, if two sides are congruent, then the two angles across from those sides are also congruent. If it's equilateral, then that means all of the angles also have to be the same. And if they add up to 180, that means each one has to be 60. So let's get these two 60-degree angles in here. And I feel pretty good about C1 and C2 falling on exactly that same point right there. And that looks like a pretty good equilateral triangle. Next one. Again, remember, pause and try it in between. 7, 7, and 15. So keeping those 7s and changing the C to 15. I don't see these circles intersecting, so it doesn't look like no matter what we put as these angles, we cannot make those 2 points fall on the same point. So we're going to have to mark that one as a no. Next one, 6.93 and 8. 4, 6.93, and 8. This looks a little more promising. We can probably make that work. So angle A needs to get a little bit smaller. 30 looks good. Angle B needs to get bigger. And 60 looks good. Turns out this actually is a 30, 60, 90 triangle, special right triangle. This is an approximation, by the way, of 4 square root of 3. If that's prior knowledge that you have, you know about those side length ratios of a 30, 60, 90 triangle. So that one's a yes. 5, 5, and 9. Having put the side lengths in, this looks like it'll work. Let's see if we can just make these. I think 26 looks about right. 26. And this one needs to get smaller. Looks like 26 might be a good bet for that one too, which makes sense because if these two side lengths are the same, then of course the angles will be the same also. So somewhere around 26 degrees. That looks like a pretty good triangle. We'll mark that one as yes also. Okay, fifth example is going to be 2, 3, and 7. These look to be too far apart to me. I don't think I can make them reach. There's no intersection of the circles. So that will be a no. Next one, we're just keeping the 2 and the 3, and we're changing the 7 to a 5. Okay, that looks a little better, but I don't know if it's better enough. It looks like where those circles are intersecting happens to be on side length C. So the only way I can make the endpoints, the C's, on that intersection point is if A and B actually fall on side C, with these angles being 0, and that's not really a triangle. So it's close. We're going to have to count that as a no also. And last one, 2, 3, and 4. So let's make that a little bit smaller, make C 4. There's a little bit of overlap now, so let's see what we can do to make this work? Maybe this is 30, looks like it was a little too big. 28, too small. I'm going to force it to be 29. Let's see if that works. And then the other one needs to get bigger. I think it's probably should be around, looks like 47. So I think I've got a triangle there. Now, looking back on what we've done, it was yes, no, yes, yes, no, no, yes. Just take a minute and think about this. What was in common between the ones that worked and the ones that didn't work? Think about the pictures that we saw as well. Do you see a pattern or a rule that we can write? In order for side lengths A, B, and C to determine a triangle, it must be true that A plus B is greater than C. Any two sides, if you add them, it must be greater than the other side. That's a strict inequality. Greater than, not greater than or equal to. We saw one where two sides added up to the same as the third side length, and that didn't work. It has to be any two sides add up to something greater than the third side. So now that we know that, let's try a couple more examples. Does this work? 5, 6, and 12. Well, just looking at it, 5 plus 6, that's 11. That's not bigger than 12. So that's going to be a no. If we need to see it over here, 5, 6, 12. Those are not reaching each other, so no matter what I set the angles to, they won't meet. Second one, 3, 8, and 9. Well, just looking at it, 3 plus 8, that's 11. It's bigger than 9. 3 plus 9, that's 12. That's bigger than 8. And 8 plus 9, 17. That's bigger than 3. So no matter which two sides you pick, they add up to something bigger than the third side. I think we can make that work. There's a pretty good triangle. Last example, 4, 7, and 11. So as we talked about, 4 plus 7, that is 11, equal to 11. It's not greater than 11. So I wouldn't expect this one to work. 4, 7, 11. This is another one, since these two add up to equal to this one. The only way we can make these work is if we have them fall on the side length C. So that doesn't make a triangle. Here's a little extension to think about for next time. Recall that I said any two side lengths have to add up to greater than the third side. So this is a topic that's coming up. This is also part of that same. So this is actually copied and pasted from a Virginia SOL test. If you have one side length that's 63 yards, one side length that's 84 yards, what is the range of possible sides for the other one? See how far apart Noah and Ben could be. So we'll discuss that in the future. But for today, let's wrap it up with an exit ticket. Of these four choices I've given you, only one of them works. Which set of side lengths can form a triangle? Let me know which one you think. Pause and think about it before I tell you the answer. So now that you've done that, 7 plus 8, that's 15. That's not bigger than 17. A is out. 9 plus 10 is 19. That's bigger than 11. We're good. 10 plus 11, 21 is bigger than 9. And 9 plus 11 is 20. That's bigger than 10. So B is the one that looks like it works. That's the correct answer. The other one should be wrong. Let's just look at them. 3 and 6, that adds up to exactly 9. So this is one of those straight line triangles. And Last one, 1, 1, and 4. 1 plus 1 is 2. That's not bigger than 4. So those two side lengths will not be able to reach each other, and we can't make a triangle. All right, well, thank you for your time and attention. Hope you enjoyed the lesson, and we will see you next time.